Alright, let's start. So in this stream, I'm going to try to show how to create something in Go that will take a struct or some type in Go and convert it to something in Typescript. So for example, a struct would be converted to an interface, and that's going to be basically the main thing I'm going to focus on. So this is just an example. We have a struct with just some fields in it, and we'll export it exactly the same names. And we can have a reference to another struct inside one struct, and then this will be translated as a reference. Technically, this would be a pointer, but the point is when we convert this, when we encode this as JSON, and we parse it on the client side, it's going to be this kind of thing. And when we serialize, or when we convert this thing to JSON with an embedded struct, the embedded struct will be just flattened into the resulting interface. So this is a brand new project. I just have a mod file and a main file, and I think I wrote some code here before, but I removed it for the stream. So I think we're going to need basically to convert this to this. I already have a code written for it somewhere else, but I'm going to show how to do it from scratch. So I think we need a struct to describe the struct that we're converting. And the only thing we need basically is the name and a list of fields. And for each field, we'll need the name and the type. And ultimately, we need the type from Typescript. But if we treat it as a data, we need the type in Go, and then we need to convert that to Typescript. So let's just do that. So we have a struct called struct info, which has the name of the fields, and the fields have the name and the code type and the TS type name. I'm not sure about whether we need this or not. Let's take it out for now. So let's do make an instance of one of these structs, and we don't need this. We'll just generate a type info for it. So we have to take an interface, and well, an empty interface, because that's how Go works. We cannot tell it directly, hey, we cannot pass the type directly here, so we just instantiate it and pass that instance. And we don't care about the instance per se, we just care about the type. So we use a reflect package to get the type of that instance. So what we need is we need the name of the type and a list of fields in the type. And to get this information, basically use the reflect package. And within the reflect package, there's something called typeof, which is a function that returns you the type. And the type is, well, the type has a whole bunch of things that you can use depending on the type. So let's take a look. Let's just take the type off and then do print it. Let's just say what it does, and we'll return null for now. We don't even need this. Let's just do this, and let's run dot. Okay, so it knows the name of the type, which is user login info. If we go back and look at this, there is actually something called name, which we can use. So let's see what that does. that prints the name exactly how we want it. What we need to output in the TypeScript definition. So we will use the name to output the TypeScript name. So let's just use it. And let's make TypeScript type name just because maybe we don't need that name, we need that type, maybe. Okay. And that's not what we want. We want the output. So and the output's going to be that, and we can call this actually result. So since we're taking the type, okay, so we have that. Now we need the list of fields, and the fields are, well, it's a bit weird, but not so much. So there's a method called field, which will get, which takes the index of the field and gives you information about it. But there, to get the number of fields, there's a method called numField. Okay, so we can use them to iterate over the fields. So let's just iterate over these fields and see what they are. Okay, so we have a bunch of fields. It knows the name, I guess we can print it nicer if we use the printf with the magic string to output more information. So we have a reflect struct field with a name, package, type, and so on. So we care about, I guess, the name and the type. And the name is not the type name, the name is the name of the field, right? Like user ID is the name we gave here. So this comes up here. So we have our own struct field info. And the name is field.name, and that is not even a method, it's just a field of the field info. and the type is the type, and so I have two variables. One of them is field and one is sField. Sfield is our own struct field, and field is the reflect field, and there's no reason why I chose this here and this here. Could be any name, doesn't really matter. So now when we run it, we have more information, but we can't really see the information because it's all everything is just a type. So if we're going to turn this information into an interface, I think it's not going to be that difficult. So let's describe struct and I don't want to return a string, and I don't want to output directly to stdout. Let's take a writer. We can do this. Yeah, let's see what that does. Let's see if that works. What is it? It's in OS. You may notice I don't format my code correctly using Go format, and I don't really care. So let's start to stdout and type info. Let's see if that does anything useful. No, because we need printf. Okay, so we can already print the header of the interface. So we already halfway there. And let's just close it. And then we can enter it on the fields. Okay. So it should be easy. Just repeat what we just did. This time it's the name, followed by the type, semicolon, and the name is Typescript type, name of the field type, but that's the type, not the name. So the name is field.name, and we can run this. And yeah, this is wrong. It's almost working, except not really, because of this. And I guess we need to indent here. So there you have it. It's working. We already can create a Typescript type for this. And this should work. So let's see, let's commit that. Yeah. Okay, so now we need to do something else. We need to make it work for when we reference another type. So if we use it for user profile, so we just create an instance of user profile and try to generate its type. And if we run that, we'll run into a problem, which is it does the user profile correctly, but it refers to this thing which doesn't exist. And it refers to this time here, which also doesn't really exist. So for time, what we want to do, we can create, time is going to be serialized as a string. So we are going to create, what do you say? A thing that tells it, hey, this is going to be a string actually. So let's a tag, and let's just call it ts string. So this is a valid tag, or should be. Okay. So we have two problems here. One is we need to parse the tags to get the actual type, and if there's a user provided custom type, then we don't care about the actual type when we output. So the field has custom type, which is a string, and if it's set, then we don't use the type. So when we output, we do this. We'll refer to the custom type, and if it's not set, then we use the Typescript tag name of the type itself. So this should still work. It should not break anything, except now we want, when we parse the struct, we want to parse the tag, and we want to refer again to the reflect package. So in the field function gives us a struct field, and the struct field has a struct tag, and we need to get something from the tag. Let's look up get okay, I guess we can just use get. Actually, we'll use lookup. Get is fine because it's going to return an empty string and we don't care. So I guess that's not going to be too hard. Custom type field dot tag dot get ts. Cool. So now this works. That was easy. So now we need, if we find a type that we haven't seen before, we need to process it as well. So now we don't just have one struct info, we have a list of types that we care about. So we'll create another struct to represent the state of our system, or parser, I guess. As a side note, I don't have any title for my stream, so let's set one. Go handmade struct to df interface. Okay. So we have a, what do you call it? I think, I don't want to call it parser. Type linker, which is, well, I guess a list of types. Yeah, types, which is a list of reflect a type. And what we want is, so let me say one thing. Inside here, maybe the first instinct is if we see a type that's itself a struct, then we just recursively call the same function on it. But I don't want to go down this path for many reasons. One of them is, as we are processing, we never want to be in a mode where we could go into an infinite recursion. So what we do is we just queue the type for processing at a later time, and what do you say? When it comes time to process it, we decide whether we need to process it or not, or we want to do something different, or we can see that, hey, we've already seen it. So let's do it that way. And let's say, let's make this a method. Although, no particular reason. Let's just make it a pure function. So now, it's not the list of types. Let's make it a list of struct fields. Okay. And there's no need to return anything per se. And when you describe, yeah, sure, that's fine. Okay. So this is not going to be resolved. This is going to be called sinfo, and we're going to add it to the linker's types. So linker dot structs append. Right. Now, what we want to do, no, this still doesn't work. Right? If we run this, right, this has to be plain object. Let's let's make a function that just loops over the structs and prints all of them. And it will be the same as the other one. It will just take a writer. And let's keep a space between let's keep a space between items. So now if we run this, it will still only be one type. And this is not right. Okay. I guess no particular reason why this is a pointer. Anyway. Right. Okay. So now this prints, and we still have only one type. So what we want to do is, as we process through the types, if we see something that is itself a struct, we want to queue it for processing. And we want to process the queue once we're done. What's the use case for this project? The use case is you are writing something on the server side in Go, and you have a front end written in Typescript. And you're going to send data back and forth between the front end and the back end. And you want the types to match. So we're going to send some data that is coming from a struct, like this. We're going to serialize it to JSON and send it to the front end. And the front end has to parse the JSON and know what's in it. So of course you can just write the interface yourself and change it every time, but I don't want to do that. So we're going to, anyway, that's the context. There are some libraries that do something similar, but they're not perfect. You have to kind of fiddle with them to make them do what you want. And anyway, I want to show that this is not really that much of a difficult problem. It's tractable. Anyway, if you want to do a full 100% solution that works for everyone, then it's maybe that's not so tractable. But if you want to do a solution that works for you, that covers your own use cases, then it's very tractable. And I think in the long term, you get much more return on it than if you were to use a library that was written by some other people, and that library tries to cover all the use cases except for your particular corner case that the author of that library did not think of. So anyway, thank you for the question. So the idea here is we're going to use this struct as the entry point to the system. And we're going to notice that we have a struct here as well. So we kind of queue it. And once we're done with this struct, we process the rest of the queue. So what we need to say, hey, is this thing a struct? And for that, Go has a thing called kind on the type, and it tells you if it's a struct, it will tell you that, hey, yes, you have a struct. So we can use that, yes, if then queue type. Let's call this process type, and let's just take the type directly. And yeah. And this will just be the type. And I don't like this style, to be honest. Just because if you have a struct definition and then you put many things inside it, it's going to be a bit weird. So what I'm going to do is okay, we need these guys. So QType, let's see, Q instance, and let's call it types. So yeah, let's just call it process. And okay, so Q instance, we'll just actually call QType. It's just a convenience method. So when we queue a type, we need to know that whether we've already seen it or not. And if we've seen it, we don't queue it. And if we haven't seen it, then we, well, add to the queue. So the queue itself is just a list of types, right? And we need to know whether we've already seen it or not. So we can have a list of process types, or we can have a mapping that takes the type and tells you whether it's a process or not. I'm not sure about the mapping because the key to the map maybe cannot be an interface, and the type is an interface. So anyway, types are comparable, so they can be used as map keys. Okay, so they can be used as map keys. So we can just do that. Scene types, the map from and now we need us to initialize the type linker because it uses a map. So the key type will basically say if linker dot scene types t return, otherwise add it and see it. And the process will just process all the types one by one. But well, as you go through the queue, things can be added to the end of the queue. So I'm not sure if you want to do a typical loop or do something else. We could just go over the queue. Let's just do the normal way. Process type. And if during the queue, if as we loop the queue is changed, I'm not sure what's going to happen to this range. But let's run it and see what happens. And we have assignment to an entry in no map. Okay, so we still only have one item. So I'm not sure if we did not process the queue or not, or what, but I don't like how this works. So let's do it more stupid way. So for len enter dot queue less more than 0, just yeah. Let's do this to pop the first item, process it, and then go again. Okay, so now this works. So we have the user profile, we have the user login info, and then we have time. And we have time because we have a reference to this time here, even though we have a custom type for it, but it says, hey, this is a struct, so we'll add it. But we need to not add it because it's a custom type. So only do this if this is not a custom type. Right, because if we have a different type for it, then we don't care what the actual type is. Okay, and I don't think we have enough new lines, so let's just add another one. Okay, so we have the user profile and the thing it refers to right after it. But of course, this end thing is wrong and the bolting is wrong, so we need to do something about that. So we need to know if the type thing is a native type, we need to map. Anyway, let's just first commit this. And process reference types. Let's see type, basic type, kind. Okay. Okay. So of the kind. Actually, we don't care I don't care about that. Let's say that if t dot kind is a struct, then we'll use this. Otherwise, we can use some mapping, right? So I wonder if there's like numeric. Maybe not. Maybe not. Let's do a switch then. I don't know if we need all the end types, but just for completeness. And then 64. So if it's any of these things, just return the word number. And okay. So that should mix. What do you do with the defaults? Let's return unknown with with a comment that gives us the actual name. I don't know if that's it. Let's just return unknown. We might just want to debug. Warning, don't know what to output for this. Oh, is active as boolean. We forgot the boolean. Okay. So did we forget anything else? Array and interface. It's probably interface that is going to bite us if we ever use it. Map might need some work. A pointer. Is there a pointer? Unsafe pointer? No. But PTR. Well, let's see what happens if it's a pointer. Okay, don't know what to output for type, and doesn't even tell us what the type is. doesn't know what the type is. Well, so if it's a pointer, we get the type name for the pointer type, because JavaScript does not have pointers, or everything is a reference anyway. Type, and there must be something that gives us a reference type. Returns the elements type. Okay. Okay, but we're not processing it now. So what we need is, if we see a pointer, we need to process it. So it's not just a struct type that we need to process, it's the element so this is one condition. Let's actually do a switch like we did there. Switch. So the element thing is for array, channel, map, pointer, or slice. Channel, we don't care about. Map, we probably do. Let's go. Array, I'm not sure. Well, array and slice are basically the same from Typescript's point of view. So let's go with the pointer or the map or the slice. Case reflect dot ptr, reflect dot slice, reflect dot array, q type anchor as field dot element. I think this should handle this case. Reflect. Okay. So when it's a pointer, we handle it. What if it's an array? We print it, but we don't know how to print that. So when we describe it, we need to print the array first. Well, actually, in TypeScript, it's like this, I believe. Okay. So we have an array of user login info. And what if it's a map? What if it's, for example, friends, which is a map from int to, I don't know, this. Let's do this. What if we have this? the key is going to be int, and we're going to queue an int. And I wonder if that works. So if it's a map, we have the key. Okay, so if it's a map, we have the key. So the Typescript for maps is it's a bit dumb, but it looks like this. And then the key type, and then the value type. So the key type is kind of like that, except this would be key. And when we process, when we queue, we need the key and the value. But now we're going to queue this thing, which is an int. And I'm not very confident about what's going to happen there. Yeah, instead of non-struct type. So when we process, when we queue type, do we check that it's a struct? Okay. So if t.kind not struct, then we don't care. We don't care. Or do we do this switch statement inside here? Okay. So this seems to have worked. This works. Now, we have this check on the type. And we have a similar check on the type here. When we queue the type, we decide what to queue exactly. Is it the type itself or the element referred by the type or something else? It's not clear that this should be here and not here, because we might want to do the same thing from somewhere else. So for now, I'll just leave it to do, or fix me, maybe move this logic to queue type. And we're going to do this handle, well, arrays and maps and pointers. Okay, so we're pretty far ahead. Now we need this. We need to handle embedded fields. And I think this is not going to work. No. So it gives us the embedded field as a field with the name and type of itself. But that's not really what we want. What we want is when we see an embedded struct, we take the fields of that struct and treat them as if they are fields of our own. So we take the fields of user login info and treat them exactly as if they were the fields of user basic info. So This loop, where we iterate over the fields, needs to be we only do it for the fields that follow the type itself, but we need to be able to iterate on the fields of a different type. So we need this in a separate function. Well, let's make it an inner function here. Fields. And then we basically just take this whole loop, almost, move it here, and now the basic case becomes this. Just add the fields of the type itself to itself. Let's make sure this works. Okay, it does. It works in the wrong way still. So struct field. This thing, anonymous, tells us that it's an embedded field. So what we need to do is if field dot anonymous, we do not process it normally. Instead, we add the fields from its type to our own. And we cannot reference our own because we are an inner function. Well, fine. Okay. And we have a Stack Overflow. So what's wrong? If we are iterating over the structs of a type, we are iterating over the wrong thing. Okay, so now we have a user with an info, and the fields of user login info are embedded exactly as we hoped for. And yeah, this helps us very nice. Let's do something else. Let's embed two things. in one struct and see if that works now. Because why not? And we need the user profile as a starting point. Okay, so we're not processing user login info. Why? User profile. So because this is a pointer to a struct, and so we should fix the readme, because key is a pointer and we should be able to say, hey, it's a pointer, so let's process its element instead of itself. Right, so yeah. So the start of the Q tuple with this special check where we decide what to do. So the main logic of the function is, in the struct case, everything else is to go through the elements and find the reference to the struct itself. Well, what am I doing? I don't care about that. So yeah. So if it's a struct, we just actually process it. If it's a pointer, yeah. This is going to be recursive, which is fine. Okay. So this works nicely now. And we can say basic. Okay. So we have user basic info and user login info. And right. So user login info is both embedded and referenced. So it's embedded in the user profile and it's referenced here. So yeah, this is fine. So this basically covers, I think we've achieved all of our objectives. We have code that well, the comment is not out of date, but we have all the cases that we want covered. So this covers the basic case. We might have to fix it some more to make it more robust in the future, but for now, there you have it. You have a thing that converts from Go struct to Typescript interface. And I don't think it was that hard to write. Obviously, I've written it before, but even if I haven't, all you need to know, the time probably spent most is in looking through the documentation to find out what exactly you need to reference to know the information you need, and getting your head around the struct tag, for example. There are still things we're not doing. So for example, if you do this, we do not recognize it. We will still output the word name in uppercase, but doesn't matter too much for now. We can add support for it later. I mean, you already know how to do it, right? We already dealt with the tag. Now the JSON tag is not just name, it can have other parameters as well, so some care needs to be taken, but not really so much. So if you want to support this, I'll leave that as an exercise to the reader. For me, I probably never use it. This is the struct, and these are the fields in it, and I want to use them as they are. I don't want to translate in my head between the front-end name and the back-end name for things. If the thing on the front end is called, if the thing on the back end is active with a capital I and a capital A, uppercase I and A, I'd rather have exactly the same name on the front end. So this is it. Thank you for watching, and I hope that helps you in some way.